welcome. We are group 4. This is our presentation on acid mine drainage. Acid mine drainage, or AMD, is considered one of the most severe threats to water systems brought about by mining according to earthworks.org. Acid mine drainage is defined as the flow of contaminated water that has come into contact with iron, sulfate, or other metals within the mining site. As a result of this acidification from said pollutants downstream, ecosystems are negatively affected. A healthy stream will retain a pH of 6.5 to 7.5, but a stream affected by waste drainage will have a pH of 5 or less. As demonstrated in the figure to the right, when the pH rises above 3, the iron precipitates out, settling out onto the rocks that line the waterway and give the water an orange color that's often described as yellow boy, a term we will touch on later. Acid mine drainage can originate from anywhere on the mining site where water or air come into contact with the sulfides, including waste rock piles, tailings, open pits, underground tunnels, and leaching pads. With PA having the highest number of coal mines, it is by no surprise it's our largest non-point source pollutant and affects more than 2,500 miles of streams according to the Department of Environmental Protection. To the right is a historical atlas by both the Pennsylvania Department of Environmental Protection, Office of Active and Abandoned Mining Operations, and our very own Pennsylvania State University.
So here we have some effects on organisms caused by AMD. We have effects on aquatic life and plants. For aquatic life, pH and fish are the most affected. For pH, the acidic conditions kill the native bacteria, which in turn affects the entire ecosystem. And a low pH also disrupts the flow of sodium and chloride ions in the bloodstream of fish and insects, which results in the death of fish, which also impacts ecosystems that rely on fish as a food source. Fish themselves suffer from impaired respiration when directly exposed to metals and hydrogen ions, and the presence of iron hydroxide in the water destroys habitats, areas for spawning, and reduces the amount of fish available for food. Plants are also affected by AMD. These kill zones decimate plant life, and the low pH doesn't always allow for plant life to grow near the streams, which reduces the value of the ecosystems that live in or around the streams and also for food. We also have some effects on humans, such as contaminated drinking water and health problems. With contaminated drinking water, you can get health problems such as skin irritation, kidney damage, and neurological diseases because the water is not always consumable after filtration. Restrictions are also applied to recreational uses of streams that are impacted by AMD, so this could result in things like no boating or canoeing or fishing, which takes away from tourism. The sulfuric acid also corrodes different infrastructure like bridges, dams, and wells, which makes transportation and commuting in general more complicated for the population. And AMD also increases pollution by leaching toxic metals such as arsenic, chromium, and lead from waste rock.
So water system impact is also very important part of the AMD treatment. AMD, which also includes the yellow boy, which is the ion unit in the water and cause the water turning to the yellow, like the picture see that, and also the pH will raise to 3 or more. And also a very important part of the water system impact is the trace metal, which also includes the heavy metal, toxic metal, and that only can dissolving when the water in the low pH, but it is very toxic and it affects the environmental. And also it has some economic impact, which is like from the water cleanup, from the both passive and active imitation, and also it will be affect the tourism because the water is contaminated, so the fish die, plant die, something like that, so people will not go into the impact stream to tourism that. So it will be cause the economic impact. And also also after the damage from the AMD, you need to reconstitution that. So from the drainage, bridge, and dams also will be affected by the acid. So if you want to repair that, you need to cost a lot of money and a long time to solve the problem. And also it will be infect the human life. And also here is some solution for the AMD, and which we're talking later.
Okay, so just to introduce the most basic aspect of the solutions, any treatment of acid mine drainage involves chemical neutralization of the acidity, followed by the precipitation of iron and other suspended solids. So most cases of AMD are treated with an alkaline addition, so basically just increasing the pH of any drainage solution. Both hydrated lime and caustic soda treatments are considered active solutions because it involves adding alkaline material at the source of the drainage. So to talk a little bit about hydrated lime, which is actually the most common treatment, it's most frequently utilized by the coal mining industry. It's easy to implement, safe to handle, relatively cost effective for any cleanup solution. There are some drawbacks to it, however. It does only have a 30% neutralization efficiency, according to one study I found. It produces a voluminous sludge that's pretty difficult to handle and clean up after the hydrated lime treatment. And it does have some high initial costs just due to the sheer amount that some of these treatment solutions would require. And one cost estimate that I found, though, it's relatively cheap compared to something like caustic soda, which I'm going to talk about next. Oh, thank you. So caustic soda is highly effective at treating low flows in remote locations and for treating AMD solutions with a high manganese content. So while it can replace lime as an acid neutralizing agent, it is less cost effective. It's dangerous to handle in comparison to hydrated lime, and it does come into some freezing problems in cold weather. So it although it's less cost effective, the one figure I found on Alibaba was $500 a ton. It is more efficient at neutralizing a potentially acidic solution than hydrated lime. And yeah, that's pretty much it for the active solutions.
So anaerobic wetlands are a passive treatment system. Sort of the idea is to go into an abandoned mine area and reform that area to hold water in the soil. And these shallow ponds or pools would promote biological organisms in those systems, which would convert the toxins into insoluble forms, which would precipitate out into the soil. After that precipitation, plants would then absorb and convert those sort of toxins into more organic forms, which could then also be removed from the system afterwards.
So next, it's another form of passive treatment, and it is anoxic limestone drains. And ALDs are a system of drains that are about 30 meters long and 1.5 meters underground that are filled with limestone. And in these systems, only anoxic water is introduced, and this is important because it prevents air water from going through the system, which means that only the harmful substances that cause AMD are in the system. And when they are in here, the limestone reacts to the AMD and produces the CO2. And when CO2 is produced in the system, it is unable to escape, which then increases the overall alkalinity. And then after this is done, the iron that is in the ALDs remains in its reduced form, which prevents the formation and precipitation of iron hydroxide from occurring, which means that it's helping to remediate the formation and further spread of AMD within the source.
Another possible solution would be to reduce mining operations. Reducing mining operations would limit future acid mine drainage. This solution offers the most benefit to the environment. If mining operations are significantly reduced, the effects of acid mine drainage logically will follow. Reducing mine operations would require legislation to legally bind mining companies. This could be done with further contract requirements on future mines, or another method might be to tax an imposed tax on mined goods, making them less profitable. Legislation has many possible methods to stop or reduce mining. The biggest hurdle with this solution is likely public opinion. Many people support mining and the goods it produces. Societal changes would need to be made to reduce public reliance on mined goods. Other solutions rely on mined goods, namely lime. According to DEP's website, lime and other aggregate materials are the most common non-coal mines. This means new mines are made to solve the problem of acid mine drainage. This is a big problem because Pennsylvania has a rich mining history. But through taxes and fees on mining companies, an alternative economy could be supported. One possibly based on exported natural resources, tourism, or simply a more tax-reliant community.
And then finally, we just have some other solutions that can be used to help remediate the problem. And the first one would be to fill in these abandoned mines. And this can be done using materials that prevent the formation of AMD, such as flooding the mines with water to remove the oxygen that is necessary for acid mine drainage to form. Or as we previously discussed, using alkaline materials to help prevent the formation of acidic water. Next, we have the relocation and isolation of mine waste, and this involves isolating waste from interaction with groundwater by moving the waste above the water table, treating it, and then covering it with a layer of impermeable material to keep it out of the surface water so that you're not further contaminating that source. Next, we have the removal of soil, which is similar to the previous one, except in this case, you're not leaving it anywhere near the source. You're taking this contaminated soil and relocating it to a new location where the waste is able to be monitored and treated to help further prevent the spread. Next, we have bacteria control, and there's two things you can do with this, and the first is promoting bacteria that helps to oxidize iron sulfur compounds, which means you're helping to support the bacteria in these sources that can help further prevent the spread. But in some cases, there's bacteria that can help speed up this process of AMD forming. So in this instance, bactericides will be introduced to help get rid of these bacteria. And in some cases, organic waste will be added to provide an alternative energy source as a means of improving AMD treatment. And it will help produce oxygen-free conditions to prevent the further formation of sulfuric acid. And then finally, in a case of where AMD can't be prevented or remediated, the best case is to just divert the water so that you don't have clean water sources running through these AMD contaminated areas and further contaminating another clean source of water.
And that's our citation, and thank you all.